Now, what if we have some like real-world data, not just points on a graph? Can we still write the equations? Well, let's take a look at this model rocket test data. It's a model rocket club that places an altimeter on one of its rockets. An altimeter measures the altitude or height of an object above the ground. The table shows the data the club members collected before it stopped transmitting a little over 9 seconds after launch. So if we watch what happens, here's the height is 0 when it's launched, and it goes up, 54, 179, 255, 288, gets to 368, 378. Where do you think it's going to be 12 seconds after the launch? No, I don't have the answer for that. I want you to make your prediction on your paper. How high do you think the rocket will be 12 seconds after the launch? And let's go ahead and plot the points. So if we make a scatter plot of the data, when at time 0, the rocket was at 0. At time 1, we were at 54, so approximately 50. Time 2, we were at 179, so here's 150, 175, somewhere around there. Time 3 seconds, we're at 255. At 4 seconds, 288. 5 seconds, 337. So here's 300. 325, so a little bit further. 6 seconds would be 354. 7 seconds would be 368. 8 seconds is 378. And 9 seconds is 363. Now, what do you think about this scatter plot? Let's put these values into our calculator. If you've never put data from a real-life situation into your calculator, we are going to go to the Stat feature. So press Stat, and we are going to edit a list. Now, if you have anything in there, let's say like I had some numbers that I want to get rid of, if there's something in there, just go up to the list name, L1, and press Clear and enter, and it'll clear out your list. What we're going to do is take those times and put them in L1, and the height and put it in L2. So we're bringing the table over to the calculator. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to go to the other side. 0 went to a 0 height, 54, 179, 255, 288, 337, 354, 368, 378, and 363. If you need to pause it, help people fill in the, get those in the calculator, or grab calculators. This is a good time to pause it. Now, looking at this graph, could this be a linear graph? Well, your calculator can do what is called a linear regression on the data. So if you've never done a linear regression before, what you're going to have to type in, what you're going to press next is your Stat button again. So we went to Stat and then Edit to enter data. And then next we're going to go Stat and right arrow over to the Calculate menu. And we are going to do what is called a linear regression. Number 4 is L-I-N-R-E-G. And it even says AX plus B. So if I go down there to number 4, it asked if we put our x values in L1 and our y values in L2. We did. So we're going to go on down to calculate. And it gives me A, which is going to be the coefficient of x, and B, which is the constant. So it says to round to the nearest tenth. So that would be 41.4. So y equals 41.4x plus 71.4. Now, use a dashed line to graph that model on our coordinate grid. So what's my y-intercept? About 71. It should be about, give or take, about here. And it's about 40 for our slope. So 70, if I go up 40, it'd be about the 110 and go over 1. Be about 150, go over 1. Be about there, go over 1. So we'd end up with a line. Now this line does model the data pretty well. I was supposed to do dash, but I didn't. What height would this model predict for the rocket 12 seconds after it's launched? Well, that would mean we'd plug in 12 in for the x in our equation and see what we get. 41.4 times 12 plus 71.4. That gave me 568.2. Oh, it says to the nearest meter, so just 568 meters. Does this compare to the prediction you made? Does this make sense that the rocket is going to keep going up and up and up? I hope you say no, because a linear model just really isn't good. The rocket is going to start coming back down because of gravity. So let's try a quadratic model. So we still have our data in list 1 and list 2. So we're going to press stat, calculate, and then we're going to go to what is called the quadratic regression. And it's going to give us a quadratic that closely matches the data. It's a quadratic of best fit. It's not as exact as when we did the ones with the 3 points. So stat, calculate, and if you look on the list, there is an option for a quad regression. It again asks us if our x values are in L1 and the y values are in L2. So go on to calculate, and notice what it gives me. It gives me the A, which goes in front of x squared, the B, and our C. And we're going to round these to the nearest tenth. So A is negative 6.9. B is going to be 103.8. And C is a negative 11.8. So now, if I go to I can actually plug that in to my y equals, right? Negative 6.9 x squared plus 103.8x minus 11.8. And we could go to the table and plot some points. So let's do that. Let's go back to our graph. And now that I've got a table of the data, I can try to plot some points. Now this one has, and I'm going to do it in a different color so we can see it clearly. 1 is going to 85. 2 is going to 168. 3 is going to 237. Here's 225, so 237 would be about here. 4 is approximately 300. Notice that it's not actually hitting on the exact points. As I said, it's not as accurate as if we had done the systems of equations. It gives us more of an approximate. 7 goes to 370. 8 goes to 377. 9 goes to 363. 10 goes to 336. 11 is 295. 12 is 240. And what's going to happen? Let's think about it. It's going to come up. And it's going to go back down. This is a better fit because a rocket is going to go up and back down. And notice our values had started to do that. They started going really, really fast up, and then they slowed down and started going back down. Now, can we use this to help us make our predictions or answer questions about the data? Well, we can. What height is the quadratic model for the rocket 12 seconds after it launches? So we look at our table, and 12 seconds is about 240 meters. Now, is that closer to the prediction you made in the first part? Can we figure out, using our model, when the rocket's going to hit the ground? Well, let's see. It starts going back down. Oh, really, really close to 15, because that's it. It's at negative there. So could we say approximately 14.9 seconds? It's a little bit before 15.